Venn diagram is basically diagrammatic representation of a set. So this will be very helpful in studying the operations of set. Basically we can visualize the operations easily, so we can understand them easily. So first, in a Venn diagram, when we are plotting it or drawing it, you can see here the bigger set, which is called as universal set, that is represented by a rectangle, and its subsets or the smaller sets, they are represented by circle inside it. Here I have considered a set which contains numbers from 1 to 11 and some of its subsets A, B, C. So now you can see A contains 1, 4, 5, 3, 2, which is represented inside a purple circle. Similarly, you can observe how B and C are written. When you study the operations now, in a while you will get to know how we have written these elements in between and how these elements are outside. Okay, so let's move on to the operations. So first operation is union of sets. When you are given with 2 sets or 3 sets, maybe a collection of sets, so how do you take the union? Basically, what is the meaning of union? Union of sets, it is a set which contains all elements of the sets in consideration. For example, if you see here, if you consider the sets A and B, union of A and B, which is denoted as A union B, this is how we denote the union. So what do we get? We will have all the elements. What is the definition? All the elements of sets in consideration. If you see in this example, what is A union B? So union is denoted by this symbol, U, as usual. So it should contain all the elements of A and B. So what and all are the elements? 1, 4, 5, 3, 2, 7, 6, 4 and 5 we have already written, 9. So this is A union B. Similarly, if I take A union C, it should contain all the elements of A as well as C. A we have written, so 3, 2, 5 are the common elements. We shall write 9 and 8. So this is how you take the union. You just list all the elements in both the sets. Next operation is intersection. So now you might have got an idea what may be intersection. Yes, it is the set of common elements which you are considering. Suppose here, if I ask you what is A intersection B, so this is how you denote intersection. So this set will be, what are the common elements of A and B? So we can see 4 and 5 are common. So A intersection B is 4, 5. So this you can observe in diagram as well, where the circles A and B are intersecting, we have written 4 and 5 in that place. So that means the intersection of A and B is 4 and 5. This is how Venn diagram is helping us to see the elements, to understand the operations. So what is B intersection C now? So what is B intersection C now? Yes, by observing the diagram, we can see that it is 9 and 5. Similarly, you can calculate A intersection C as well. Now coming to the difference. What is the difference between sets? How do you subtract two sets? You know the subtraction between numbers, real numbers and all. So now what is difference between sets? Suppose you are considering two sets A and B. A minus B is a set which contains the elements of A which are not in B. Let's see through the example. So in this case, A minus B is, what should A minus B contain? It should contain the elements of A. I shall write this, elements of A which are not in B. So I can write 1, it is not in B. I can't write 4, 5 because it is in B. I can write 3, 2. So do you observe something here? A minus B, A intersection B, A, B and all. Basically what I did here is, A minus B is nothing but you are removing the common elements of A and B from A, right? That is, you can also write A minus A intersection B. The meaning of A minus B is also this. Similarly, you can take B minus A minus C. So next operation is complement of a set. Complement of a set, once you understand the difference, understanding complement is easier because we are considering one universal set here. So complement of a subset in it. Suppose A is a subset of X. Complement of A is just X minus A. If we consider this example here, so what will be A complement? We denote complement like this. It is X minus A. You can observe the sets here, this and this. That is, we have to remove A from X. So 1, 2, 3, 4, 5 is already included in A. So I can't write it here. Excluding that, it is 6, 7, 8, 9, 10, 11. This is the complement of set A. Similarly, try to calculate complement of set B and set C as well. Okay, so this is about the operations of sets. So you have already seen how Venn diagram is helpful in noting or in observing the operations. So next we will move on to two important properties. One is De Morgan's law, one more is distributive law. First we will study what is De Morgan's law. In fact, we can prove De Morgan's law using Venn diagram. Okay, what it is saying, A union B whole complement, if you take two sets and take complement of it, it is same as taking the intersection of the complements. We will understand this by using Venn diagrams. Okay, first what do we need here? We need A union B. Okay, we shall shade it. So this is A union B, right? All the elements of A and B. So this is A union B. Next what we want? A union B whole complement. How do we get it? It is by X minus A union B. We have to remove the elements of A union B. Then what remains? The outer part of A union B, right? So this is now our A union B whole complement. Now let's check the right hand side. That is, first we need A complement, then we need B complement, then we have to take the intersection. First, A complement you know, x minus A. So you have to remove A from x, that is this portion. Also this portion, because this is not A. We have already removed the part of A. Okay. Similarly, what will be B complement? X minus B. Yes, now you know this portion will also be included, except B, everything else. Okay? Yes. Now shall we take the intersection of these two? What is the intersection of these two? What is the common shaded area in these two diagrams? Yes, it is the outer part of A union B. Are these matching? This is A complement intersection B complement. So we have shown A union B whole complement is A complement intersection B complement. Similarly, you can also show this A intersection B whole complement is A complement union B complement. So using Venn diagram, you can easily show this. Please try it. So this De Morgan's law is not only meant for 2 sets or 3 sets or finitely many sets. In fact, you can go for infinitely many sets. So this is De Morgan's law. Here union of AIs. This notation, if you don't know, this is just noting you are taking the union of AIs, that is A1 union A2 union, so on up to infinity. Okay, you are taking complement of it, whole complement, and this is denoting you are taking the intersection of complements, AI complements, that is A1 complement intersection A2 complement intersection, so on up to infinity. Similarly, this is also true for infinitely many sets as well. But of course, countable, not uncountable. Yes, of course, if you don't know what is countable and uncountable now, it's okay. You just remember that whenever I say I equal to 1 to infinity means I am referring to natural numbers. Okay? Yes. Let's move on to distributive law. So first distributive law, it says, so you must have seen distributive law in addition and multiplication in real numbers, right? Similarly, it works with union and intersection for sets. So here A union of B union C is A union B intersection A union C. Okay, we shall prove this. This will be for you to try. Okay, we shall start that. So first, what do we need? We need A. So I'll shade A. This entire thing is A. Then what I need? B intersection C. This is B, this is C. So these two intersect here. So this is B intersection C. Then what do I need? The union of it. The union of these two means we are combining two. So what I get? Set A and this. So now this is A union B intersection C. Okay, fine. What we have in RHS? A union B. So this will be A union B. Then what we need? A union C. This is A union C. Then we need intersection. So intersection means we are taking the common, which is the common shaded area over here. See, A is shaded, B is shaded here. Here A is shaded, C is shaded. So therefore A is definitely a common region plus this common region of B and C, that is B intersection C. So here what we got, A union B intersection A union C. So these two are equal. So this is the distributive law of sets in union and intersection. So similarly you can try for second one. It will also work. Try with Venn diagrams, it will be easier. So one more question is, you can try for this. Will Venn diagram work for 4 sets? So you can try with this. So if yes, how? If no, why? Up to how many sets Venn diagram works? So this is an interesting question to look into. Okay, so go through the concepts, and if you have any doubt, write in the comment. So thank you.